Hi everyone, how are you? So hope you had a good time with the previous video. The previous video went on for 20 minutes. So I just wanted to reduce the time so that you can have little bit of interest element going in. And also some of them were telling me that it was a bit boring because the presentation was not that good, like it was not that interactive. So I just try to make some animations. So hope you'll enjoy this video. So it's a continuation of what you've seen in the previous video. Okay, so this is same, the concept is the same, but we are going to use a different method. So just a recap of what we did yesterday. So yesterday we learned, okay, what was arithmetic mean and the core idea of arithmetic mean, which is a sum of all observations divided by a number of observations. Okay, so where do we use that? So whenever you have some test to get the average of marks, to get the average temperature of a city, okay, and then the particular height or any data that you want to, and you want to have some glance at the data, so you want to find out a measure that comes towards the center, we use this method, we find this mean. Okay, so yesterday we tried in a different ways how we can find out mean using a direct method and shortcut method. The another name for shortcut method is a assumed mean. Okay, so while doing the video I just told you, what if one of the value is missing, what if one of the value is missing and you are given a mean, so how do you find out? So we just have one question where we are going to find out the value in the frequency distribution when you are given a mean. So the question is this: finding the missing observation when a mean is given. So if you remember yesterday, I was trying to relate to you to the formula that we had seen earlier. Okay, so the formula is sum of all observations divided by the number of observations, which is equal to your mean. So you have one of the value here is x, one of the value here is unknown value. So you're trying to create an equation using that formula. So once you create the equation and solve the equation, you get the value of the missing, you get the value of the missing number. Okay, so now I'm just trying to go to the next slide. How can we use the same idea, okay, the same idea in a when you're given with a frequency distribution? Okay, so let's look at this question. The mean of a given data is 21.6. Find the value of p. So which means one of the observation, one of the frequency is given as p. So if you look at the observations are 6, 12, 18, 24, 30 and 36. And the frequency of 6, the observation 6 is 5, which means 6 occurs 5 times. The next one 12 occurs 4 times, and 18 how many times does it occur? We don't know. So we have taken it as a variable, and then we have 24 which occurs for 6 times, and then 30 which occurs for 4 times, and 36 which occurs for 6 times. So this is the given data, and we are trying to find out the value which is missing over there, the p. So the mean is already given. So we have to think of the direct method. So we have to find the sum of all observations, which means 6 comes 5 times, therefore 6 times 5 30, 12 comes 4 times, 12 times 4 which is 48, and 8 times p. That's where you need to be a little more careful. It's a product of a number with a variable. It will be just 18 times p is 18p. Okay, 24 times 6, 30 times 4, and then 36 times this. So all the value has been given in this tabular column. So we'll just go one by one. So the first one, 6 times 5 which is 30, 12 times 4 which is 48, very simple to do, and then 18 times p which is the unknown value, so you just keep it as 18p. Okay, so 24 times 6 which is 144, 30 times 4 which is 120, 36 times 6 which is 216. Everything is the same like what we did in the earlier step except for that variable p. Okay, now you should be a little more careful when you add this, when you find the sigma fx. Okay, you have to be a little more careful because when you have a variable you can't add them with the numbers because they become unlike terms. So or add all the numbers and keep the variables separately. Therefore 558 plus 18p. So that's your sigma fx. Now look at the sigma f. So here there are many numbers, there are 5 numbers and one variable. So the one variable cannot be added because it's unlike them. So when you put everything together, you get 25 plus p, and then the sigma fx is 558 plus 18p. Okay, so now moving on to the next step. So we're going to use the same formula, but we know the value of mean. So we know the mean. So when we substitute that value, we get an equation, a fractional equation. So now you know well how to solve this equation. So do the cross multiplication, and if you do the solving of equation, you'll be able to get the answer. Okay, so hope looking at this video, looking at this presentation, you must have got an idea how to find out a missing value in a frequency distribution when you are given with a mean. So this is one of the concept that we missed out yesterday. So there are 2 more questions on similarly like this. So I just want you to give a try to those 2 questions from exercise 16a. Okay, so we move on to the next one, that the main focus of today's, this video's lesson. So we're going to see how to find out mean using a step deviation method. So what happens in this case? Yesterday when we looked at the question, when we use the assumed mean method, we were trying to choose one of the value to be your assumed mean and check how much each value deviates from the mean that you have chosen. So if you found out the deviations were like 150, 200, 300, so they were huge numbers. So how can we simplify this? So if we try to divide all the numbers, okay, all the deviations by one particular value, so that you can get the simple values. That's what you're going to see. So the new element that has been used here is the height. Okay, so h. So the formula is going to be assumed mean, that you choose it as a mean. Okay, so on the height, the number which you're going to divide each of the deviation, and then it's exactly the same formula that we did, sigma fi ui. Okay, ui is the deviation divided by the height, okay, divided by sigma fi. So what does this? Step 1, choose a suitable value of xi in the middle, okay, as the assumed mean, and call it a. Okay, it's exactly like the same steps that we had done in assumed mean method, only the deviation should be divided by the height. The deviation is divided by the height, okay, because the deviation was little huge number and all the deviations had one number which is in common, so you can choose that one element which may be a little bigger. So in other words, you can call it as a HCF. Okay, you can call it as a HCF. But in the next year, when you work out the mean of a grouped data, that in place of the values or the observations, you will have a class intervals. So like 1 to 10, 10 to 20. So when you have those class intervals, you should be using the height of the class. So therefore this h will have more meaning, okay, when we do it for a grouped data. What we are doing right now is for ungrouped data. Okay, so you can refer this value h as HCF of the deviations. Okay, so now as usual, like the previous thing, you find out fu and find out the deviation, that average of the deviation, then add it with the arithmetic mean, sorry, the assumed mean. Okay, these are the steps. You can pause the video here and go through those questions. Okay, and the next one, we can directly see the question that we had already worked out in a assumed mean method, and we are going to do the same thing with the same question with the step deviation method. So look at the question, the data, the distribution table is the same. Okay, so in place of d, yesterday we had the deviation here. Here the deviation is being divided by HCF 50. Okay, so because every element can be divided by 50, therefore I'm choosing that. So 1100 is your assumed mean. So the difference between 950 and 1100 is 150. So 150 divided by 50, which is minus 3. Minus 150 divided by 50 is minus 3. Now for one value the deviation is minus 3. Therefore there are 24 frequencies. Therefore 24 times minus 3, which would give you minus 72. Similarly, if you find the next step, for the next observation we have 1000 and the mean that you have chosen is 1100. The deviation is 100 minus 100. So minus 100 divided by 50 should become minus 2. Therefore you have minus 2 over here, and then the product of, so for one value the deviation is minus 2. For all the values, like all the 18 observations, it would be together minus 36. So the similar method is used to find all the u's here, and then f into ui, and then you get the sum of all fu and then sum of sigma f. Look at the next part. As usual, you're going to use the same method. Okay, so the mean is going to be assumed mean plus the HCF that you've taken. Okay, so if you want to look at it, it's just simple. You take all the common factors outside and add all the remaining factors and multiply with the common factor. It's not going to affect anything. Okay, it's like a normal factorization method of a numbers. Okay, you take one factor out and add everything and then finally multiply. So you divided every deviation by height, and here with the average of the deviation you're going to multiply the height. Therefore it will not make any differences in the values. It's not going to make any differences in the values. You will just get the same thing. Okay, so I'm not going in very detailing. You need to spend a little time by seeing the work how you can develop. I'm not going to give you any notes for the notes or discuss more on the method, because you need to think about it. You need to develop notes on your own. So what you have interiorized, the what I'm saying is my knowledge. When you hear it and you try to think, and when you try to develop an understanding, that becomes your knowledge. So what remains in your mind most is your knowledge than the teacher's knowledge. So whenever something is delivered to you, just try to make it your knowledge, and that lasts long. Okay. So with that we are concluding this chapter, finding the mean of ungrouped data. So let us summarize what we have learned in these two videos together. Okay. So the first one that we did was mean of ungrouped data. Hope you remember the formula, sum of all observations divided by the number of observation. And the second one, finding the missing values when mean is given. Okay, so and the third one is a mean of ungrouped data when frequency distribution is given, when the data is given as a frequency distribution. So the first method that we saw was a direct method. You just need to know sum of all observation, how to find the sum of all observations using a frequency distribution. That's the first part. Okay, then you add all the numbers, then use the simple formula. The formula should be one. I'm not giving you the formula, I'm giving you an idea. You write the formula on your own. Don't memorize the formula. Try to understand and conceptualize the idea of average. The formula will be there in your brain all the time. Okay, the next one, finding the missing value in the frequency distribution when mean is given. Okay, and then we used two different methods. The one is the assumed mean method, and the next one is the step deviation method. They're exactly the same. The difference between assumed mean method and step deviation method is, from all the deviations I'm trying to take a common factor out, and once I add everything, then I'm going to multiply the same common factor into it. Therefore the value remains unaffected, but the working becomes simple. Okay, thank you so much. Hope you'll master the concept of mean for ungrouped data. See you in the next video.